our main topic, which is the changing of the oil field itself from the exploration to the brown field. Here is just illustrating for you what is the main difference between different stages of the oil field. So as you can see here, the main parameters have been changed from exploration to the brown field. So I will go in a separate way, telling you what is the main difference, especially from geomechanical point of view. While exploration, as you can see here, you will suffer from limited data availability. You will always have seismic data. It may be 2D, it may be 3D, based on the availability of the data itself. You will have regional published data, and you will have some of logs from the nearby fields if you were lucky. But if you were not, you will not find any logs or data related to upcoming field. The model requirement, it would be a little bit lower. So the requirement will be restricted to PPFG model, and it may be extended to sealed rock capacity. Both of this requirement, we can proceed using the available data. So what you will suffer from is the data availability. It will be very restricted data, but the only positive 2 points here while dealing with exploration phase, that most likely you will deal with a vertical well where you find out a lower stress problem while drilling with them, other than dealing with the highly depleted wells. The other good point that you will find out a broad mud window between the pore pressure and the sand frac. It's related to dealing with virgin pressure reservoirs, so it will be a little bit good for our case. Once you go through the appraisal and development phase, you will find that you have a good data availability. So other than the exploration phase, where you find out only seismic and the regional data, you will have some sort of drilling data, the observation of the drilling itself, the mud weight have been used in the exploration stage, and even the pressure data have been recorded using RFT data, MD data. And even if you have recorded LOT, lake of test, and FIT data to be used as a calibration for the sand frac, it will be excellent. And if you are lucky and you have logged image data just to trying to capture the stress data, either its orientation or a magnitude, you will be lucky. And again, the same requirement will be PPFG model and Wilbur stability model. So once you will deal with some sort of depletion and you will start to set your platform, especially in the offshore wells, you will deal with deviated well and high deviated well. That's why the model came to be more complicated, especially on the scale of the shear failure itself. That's why you should estimate that the mud weight gonna be lower and narrow due to the increasing of the required mud weight to stabilize the hole related to the shear failure itself. Going to the brown field, again, it's too much data gonna be used, the available data. So you will have, again, drilling data more, mud weights gonna be used. You will be lucky if you have a core data just to proceed mechanical core analysis. Mechanical core analysis means more validation for your points, for your mechanical earth model. So you can do your empirical equation in your field just to be high confident in your data credibility and to be familiar more with uncertainty at each point. On the other hand, the requirement could be higher, because once you find out you are in the brown field, you should estimate that there are severe depletion in the reservoir, which is sandstones and limestones. So the frag gradient should be lower. And again, the shear failure required or the mud weight required to mitigate or to avoid the shear failure will be high. So you should expect that you will have very narrow mud weight window. So on the contrast, again, once you have in the brown field stage availability or data availability with high confidence and variation, on the other hand, you will suffer from a model requirement, which some sort it should be complicated. Also, what we need to highlight here that you may suffer from some casing collapse related to the compartmentalization between different reservoirs and the severe depletion or the delta P or pressure difference between the two compartments resulting in reservoir collapse. Also, you will be required as geomechanics specialist to do some sort of fault seal analysis just to be pretty sure that you don't have any breaching for the sealed rock, especially those on the horizontal or a vertical sealing related to the track itself. So, as a conclusion for this comparison for the early life and the late life, you can see here the blue curve is the pore pressure, the green curve is the shear failure, while this one is a sand fracture gradient, and here is the overburden gradient. So you can imagine that at early life of the field, you have data availability which is very low, validation data almost none, the available data is almost seismic and regional data, but you are dealing with a broad mud weight here between the shear failure and the fracture gradient itself. While you are dealing with the late life of the field, you are dealing with good data availability, including all of the validation point, mud weights, drilling problems, LOT, FIT, the logs itself, and even the stress parameters. But you can imagine that the shear failure came higher. As I've told you, most likely that while brownfield life, you are dealing with deviated and highly weighted well, resulting in increasing the shear failure by itself and decreasing of the fracture pressure related to the severe depletion of the reservoir. So again, it's high data availability, but still high requirement and high risk as a geomechanical model. The main issue here that you have a good discussion with the different disciplines, with the subsurface team, with the drilling guys team. You have to deliver for them at each step what is the confidence in your data and what is the level of uncertainty for your model at each step. So let's go to one other critical point, by the way. How sophisticated is the model needs to be. And here I do believe most of our attendees need to know more about the 3D geomechanics and important for some cases. It's very significant for the critical stressed areas where you can find critical faults where you have like different distribution of the stresses along the fault itself. While the 1D is very significant and very important for the simple cases of the 1D, where you can find out uniform stress regime, uniform formations. While you are dealing with heterogeneous reservoir, you have to deal with the 3D. But please do not ever forget about the estimated cost, the estimated assigned person you should use while using the 3D. So you can see here the comparison between the cost, it's very high while proceeding 3D compared with the 1D. And even the team members needed to proceed geomechanical model in the 1D and the 3D. So our recommendation, 3D is very significant, very important once you need its outputs and it's critical for you. For the unconventional reservoir, it is still the same requirement as geomechanical input data, but we will need too much data to calibrate. But again, it is the same requirement as geomechanical output. Get into addition command that we will need the fracture width simulation just to trying to find out the fracture aperture and the fracture width you're gonna simulate at a certain point which you needed from the reservoir engineer, and even the fracture aperture gonna be created and suitable probant should be used while the fracking job. Also, the carbon dioxide will need 3D advanced 3D geomechanical model. The only change from the 3D geomechanical model that you have to simulate the fault stability analysis after injection the carbon dioxide and the effect of increasing the pressure Increasing the pressure means increasing the effective stress on this formation, so it may result on rejuvenation of any fault. And do not ever forget the case studies that we have showed you at the beginning of this presentation resulted in seismicity due to the severe depletion of the reservoir. Sort of conclusion about our presentation today. Geomechanics is not just about drilling; it supports entire the exploration and the production life cycle. The safe mode window means you have to drill it between the shear failure and the fracture gradient. You have to change and update your geomechanical model from different life of the field, starting from exploration up to the brownfield. You have to digest well what is the main causes of the overpressure and to be familiar with how to deal with each case. And again, gentles, please, you have to focus on when do you decide to use a 3D geomechanical model. Thank you for your attention.